Hello everyone, I am Ravi Singh and I am from the Bennett University. Today, in this video, we will learn about the A-star algorithm. So, what is A-star algorithm and why only A-star algorithm is, why not other algorithm is used? So, basically, A-star algorithm is used to find the shortest distance between any two nodes or between any 2 points. And it is used by the mini gaming industry and as well as even the Google use this algorithm for finding the shortest distance between the any two nodes or 2 points like in Google Maps. Okay, so why only A-star algorithm is, why not other algorithm is used? It is because basically A-star algorithm take less time for finding the shortest distance as compared to the other algorithm. Now, how A-star algorithm works? So let's understand this working of this A-star algorithm with the help of the real life examples. Okay, so basically A-star algorithm works on the formula f of n is equal to g of n plus h of n, where g of n is the distance traveled from the start of the cell node. The h of n is the estimated distance from the cell or node to the target node. Okay, so suppose you you are at New Delhi and you want to go to the Mumbai. Suppose A represent the New Delhi and Z represent the Mumbai, and the edges between these represent the highways, and the value of these edges represent the distance in kilometer, and the nodes that are in between represent the different cities, and the value on which nodes represent the distance to cross this particular city. Okay, so you have to go from New Delhi to Mumbai, so you have three paths. Okay, so basically the value that are present on the edges represent the value of g of n. As I have told you that g of n is the distance travel from the starting node to that particular cell. Okay, and the value that we present on the each node, that is on different cities, represent the value of the h of n. And h of n, as I have told you, it is the estimated distance from that city or a cell to the target node. Okay, now let's let's understand about the estimation. So how estimation is calculated? In previous slide I told you the h of n is calculated using the estimated distance from the cell to the node. Okay, so how estimation is calculated? Basically the distance between the cell or target is called the heuristic. Estimated distance is called heuristic. So how it is calculated? It is calculated using the Manhattan distance. Okay, so we have on which city or on which cell you are standing. First find the x coordinate as well as the y coordinate, and also find the x and y coordinate of the target node. Then putting this value in this formula, you can calculate the value of h of n. That is going to be estimated distance. Now let's understand with the examples. To understand the A-star algorithm, let's solve this question. In this question, we have to start from the node A and we have to reach to the node J in the shortest path. Okay. As we know that the A-star algorithm works on this formula, f of n is equal to g of n plus h of n. The value, the number that written in the red represents the g of n, and the number that is represented in the purple represents the h of n. Okay. So let's solve this question. So we have to start from the node A. So node A, node B and node F both are connected. So for first we have to find the value of f of B and f of F. So in step 1 I have found the value of B and f of F. So you can see that the f of F has a smaller value as compared to the f of B. So we will move from node A to node F. Okay, but for node F, node G and node H both are connected. So in step 2 we will find the value of f of G and f of H. Okay, so f of G here have a smaller value as compared to the f of H. So we'll move toward the f of G. Okay, from node F to node G. And there is one more thing. For g of n, I have also added the previous value of the f of g of n because we are starting from the node A. So I have also added 3 plus 1. Okay, 3 plus 1. Okay, so now we have reached to the node G. For now from node G we have only one node to reach, that is I. So we will move towards the node I. So in step 3 I found the value of f of I. Now we have reached to the node I. So for node I, node E, J and S, all three nodes are connected to the node I. So in step 4 I have found the value of f of E, f of H and f of J. So f of j, as you can see, that have a smaller value as compared to other two. So it means we from node I will move towards the node j, and this is our also target node. So it means we have find the shortest route from node A. So what is our shortest node? We have started from node A, okay, then we move towards the node F, okay, then we move toward the node G. After that we move toward the node I, and from I we move toward the node J. So this is going to be our shortest route from node A to the node J. For the better understanding, let's solve this one more question. So here S is the starting point and T is our destination point. So first we'll find the value of F in all the possible directions, and we will move in that direction where the value of F remains small in comparison to other. After moving in that direction, we will find the for the other node also in the coming path, and we will move in that direction where the value of remains small. Okay, so you can see that the value of the value of F remains I mean small, I mean here the 9, and we will still move in that direction only, and after following this procedure we will achieve to the shortest path. We can reach to the destination T. Now let's learn about the pseudocode for the A-star algorithm. First we will initialize two lists, that is open list and closed list. So in the open list we will put the starting node in the open list, and we will remain the value of f of n at remains 0. Okay, then we will make the while loop run until the open list is not get empty. Then find the node with the least value of f of n in the open list, and we will declare as a value of q. Then we'll pop the value of q from the open list and generate the successor of it. Okay, and for each successor we will run a for loop, and if in for loop if the successor is found to be goal, then we will stop the searching of this successor, and then we will find the distance using the Manhattan formula as I have discussed in the previous slide. Now if a node with the same position as successor in the open list which has a lower value of f than the successor, then we will skip this successor process. Okay, now if a node with the same position as a successor in the closed list which has a lower value of ffn than the successor, then also we will skip the successor. Otherwise we will add this node to the open list. Okay, and we will end this for loop, and then after that we will push the value of q on the closed list where the while loop gets end. So basically this is the pseudocode of the A-star algorithm, basic pseudocode. Now we will learn about the time complexity of the A-star algorithm and the auxiliary space complexity of this algorithm. If we consider the worst case time complexity, so basically in the graph it may take us to travel all the edges to reach to the destination point from the starting cell. Okay, so in this case the time complexity is going to be big of E, where E represents the number of edges in the graph. And for the auxiliary space, if we consider the worst case, then also we can in the open list we can have all the edges inside the open list. So the required auxiliary space in the worst case is going to be big of V, where B is the total number of vertices. So I hope we will understand the A-star algorithm better.